As part of a wider AMRC project, we decided to explore the realms of an off-the-shelf alternative system to incorporate and develop a pick-and-place robotic process that can pick up an electrical drilling unit and install them into a drilling jig template that is widely used within the aerospace manufacturing and assembly industry. Currently within the aerospace industry, this is done either by skilled aircraft fitters or generally as a fully automated cell with dedicated end effectors that is bespoke for drilling operations. The project started off with the iConsys system that is a universal robot and has 10 kg capacity with a mere 200 platform acting as a delivery media. The two systems integrated gives the benefit of delivering a robot solution to the exact place where it is required, as the system is small in comparison to other AGV platforms. This helps in the reduction of creating bespoke processes and infrastructure that is commonly required on fully autonomous machining cells. The project started off with a relatively simple and novel idea of integrating key features for datum capture on drilling jigs. This is using the UR10 system with its built-in force and torque sensors to find a point in which would become our datum position. The datum capture was developed several times over the course of the project and came up with some novel ideas to separate the features away from the drilling jig, as well as the actual datum capture tool that the robot uses. The progression of the system has seen the process traversing from a 3D printed drilling machine and drilling jig through to a metallic system that is inverted above head height, installing an actual working electric drilling machine with all ancillaries, showing how the system would work in areas where ergonomic constraints may be seen on the people who work in these areas day to day. During the progression, a secondary datum capture system was created, whereby the option then for one or another datum capture system could be utilised depending on the application and sizing of a drilling jig that was to be used. The 321 frame capture actually utilises a drilling machine, meaning that where a relatively square or rectangular shape is seen, the system can quickly datum and begin drilling straight away, meaning no other datum capture tooling was required. However, if a drilling jig cannot be captured using this method, the original datum capture utilising a separate drilling jig and datum pin can be used, so all drilling jigs therefore can be covered with these methods. Further ideas and progress could be realised from the project, such as separation of the MIA and UL platform, allowing more flexibility and autonomy from having the systems separated. Other applications such as part installation, actually placing the drilling jig into position whilst the skilled aircraft fitters finally install the jig in place, will help ergonomically. Other areas such as digitally enhancing the process by having a digital twin operating system monitor and control the end-to-end method would allow further enhancement.